like to thank the Academy, and I feel I should be holding an Oscar when I say a statement like that. But seriously, it's great to have this opportunity to talk about some ideas that have been percolating within me for a number of years now, and it's only because of the National Academies of Sciences that I've been able to now formally pursue this concept of thinking about how space influences cognition. So as a cognitive psychologist, I think a lot about thinking. As a cognitive psychologist that studies teams, I think about how teams influence thinking. And now I'm starting to evolve that into a broader spectrum. But I wanted to start with a couple of images here. And even though these look really disparate, there's actually some similarities between these two images. And they have underlying elements being associated with art on the one hand. So on the left side, you see actually an award-winning illustration. The National Science Foundation funds these competitions annually for art and science, and this isn't the 2005 winner. When I found this one, I didn't realize it was that old because I have it on my wall in my office. But what this is illustrating is a neuron about to fire. Deep within the brain, we see a trigger across a synapse. We see molecules about to be transmitted. And this is illustrating essentially thought about to occur or thought in action. And the question we're wondering is where does thought happen? Where does thought occur? Where does it reside? And we still don't have a full sense of what that is, but what happens is something in the environment, in the external space, triggers you. Your sensory system is activated. That activates the nervous system. And within the brain, these neurons fire, and this is how we think of as thought, these billions of neurons firing within the head. And this is where ideas emerge. Now, what does it have to do with something on the right here? It's not something from Dr. Seuss. It's a real building. Does anyone know what that building is, by the way? Okay. So it's actually an infamous building. It is at MIT. It's a building where they have the Artificial Intelligence Laboratory. It's the Stata Center, and it was designed by Frank Gehry, and he designed it a number of years ago. And actually, I wanted to show this one because that's where I started to first think about this topic. And I was there for a completely different purpose. I was at a meeting up at MIT with the Artificial Intelligence Lab talking about collaboration and cognition, and it was in this bizarre building. And I just had to ask at some point, why? What happened here? Why did they build this building like this? What's going on? And I just asked a random person, and they says, oh, it was designed so we bump into each other. And I said, what? He says, yeah, there's no real hallways or anything, and you have to walk around everything, and you always see people. So it was designed so people would run into each other. And I kind of filed that away, and I thought about it. And I was actually at this meeting. It was a multidisciplinary science meeting, so it was psychologists and scientists and various stripes there. And I was thinking about that, well, it's kind of interesting. They've designed a building, hopefully, to facilitate collaboration. And so I started to think about this some more, and over the years, I started to look into this a little bit more formally, and indeed, when I did some research on this building, Frank Gehry had some specific ideas in mind. So he designed it so you have these workspaces, you have these meeting spaces, you have these hallways where you always will see people. He wanted to design for community, he wanted to design for interaction, he wanted to design for what we now call these kinds of productive collisions. And what is going on here is he's trying to get people to run into each other, he's trying to get people to meet each other, and he's trying to facilitate essentially the generation of ideas. So the concept here is with interdisciplinarity, you throw all these people into a building, and you don't want them just to hide in their office. You want them to interact. You want them to come together. You want those neurons to fire between them. So he's designed this with a specific purpose in mind. And being Frank Gehry, he thought, of course it's going to work because I designed it. And that's a whole separate story that I don't have time to go into. MIT sued him in the end for a number of other reasons. So it's got quite the history. But when I was looking at it, I was happy to see that people are taking this issue very seriously. That is, how do you design for collaboration? How do you build a space that's going to facilitate collaboration, and in my view, facilitate collaboration and cognition? So they're creating a context for this notion of productive collisions. And JD mentioned my work with the science of team science, and this is why I started to take this more seriously, because the science of team science is a group of people who want to study scientific collaboration. We want to study it because we want to understand it, because it's a very complex form of teamwork, but we want to also improve it. And invariably when we would have these meetings, we'd invite a president or a provost, and they'd get up there and they'd say, oh, we just built this $100 million complex. It's going to facilitate innovation and interdisciplinarity on campus, and we're going to become much better at what we do. And being a scientist, I'd say, show me the data. How do you know? You just invested all of this money. How do you know it's going to work? And I found that particularly annoying because $100 million is a lot of money. You could fund a lot of science for that amount. So I found it bothersome that people were making these claims that you could design for innovation and design for collaboration in the absence of data. And indeed, I was very pleased when I saw that people were trying to study this phenomenon. And this was one of the papers that we came across with, and we actually brought it into our National Academy study. This was published by Felix Cabo and colleagues at the University of Michigan, where they were studying one of their interdisciplinary centers. And they wanted to see how movement through this space, through this office, actually altered the collaboration. So they looked at people moving into this new building. And indeed, they did find that a new building, putting people in a new building, did increase collaboration. So, kind of interesting, but not that intriguing. What was more intriguing, though, was the next idea is they found that being on the same floor actually increased collaborations more. So, proximity, that's going to be helpful. Getting back to this idea of productive collisions, they're near each other, so maybe these neurons are firing across one another. But the more intriguing one was what they called this zonal overlap. And that's what you see highlighted in this diagram. And that's basically the kind of shared walkway, the shared space, the shared hallways that these people had in their day-to-day interactions. And the interesting finding was that they could put a metric on how much collaboration was determined by the amount of shared overlap on this floor. And they found that for every 100 feet increase in shared overlap, they had a 20% increase in publications and grant projects. So here we have the data to show that you can design for collaboration and cognition. So a very important finding, and we wrote this into the report because this is important. You want to be able to design for collaboration, and when you put smart people together, you want good things to happen. But can we do more is the main question that we're asking now, and because it's not simply about buildings or it's not simply about brains, it's about buildings and brains and bodies. And we want to think about these spaces not just for these collisions, but as a cognitive psychologist, I'm interested in the cognition that emerges when people collide. So basically they've been studying, well, what happens when people run into each other? They produce some output. I want to know what led to the production of that output. And the argument I want to put forth is that you cannot design for cognition and collaboration without really understanding cognition. So I guess that's a kind of a disciplinary arrogance on my part. I'm a cognitive psychologist, and I admit, so I spend a lot of time thinking about thinking. So those people who are designing, and this is why I'm intrigued by this kind of collaboration, those people who are designing spaces, let's talk. Let's think about thinking and how we can better design for cognition and collaboration. And to illustrate where we've been going, I want to talk about a new theory, an emergent theory in cognitive science about what do we mean by cognition and collaboration. And I have two images here that illustrate something. So on the left-hand side, you see someone taking notes, someone making a list. And we can think of this as essentially an act of remembering. And we make that point because usually when we think about remembering, we think about something that happens in the space between the ears, something inside the head. But in the view of extended and enactive cognition, we think of remembering as something that happens between the brain, the body, and the world. So the memory is actually in the list making. And on the right-hand side, we see someone working out a problem on paper. And we talk about that as an act of cognition. The cognition is occurring not in the head, the cognition is occurring in the act of working out the problem on paper. And if you're not familiar with the esoterica of cognitive psychology, this would have been kind of heretical because they believed that cognition only happened in the head. And we thought information processing, things happen inside the head. And we realized that no, we need to think more broadly about the link between the brain, the body, and the environment. And we've come up with this theory of extended and inactive cognition. And actually, we can thank philosophers for this because they're the ones that were questioning the way we were thinking about cognition. And philosophers have been thinking about this for a number of years now. And Andy Clark has been a champion of this idea. And he notes that there is this kind of interconnected activity, this loop between the brain and the body and the environment. He refers to this as this kind of integrated circuit. And here, in this case, the thinking is on the paper. It's not in the head, the thinking is on the paper. And there's an illustration that's used often to talk about Richard Feynman, the famous physicist from the 20th century. And the illustration of this is a historian came across his notes. And the historian went to him and was really excited. And he says, I found a record of your work. And Feynman, being Feynman, kind of an abrasive guy, says, that's not a record of the work, that is the work. And the historian says, well, no, it's the record of what you did. And Feynman says, no, I did the work on the paper. That is my thinking. Those are not notes or a record. That is the thinking. The thinking was on the paper. And Feynman was making a powerful point. He's saying it wasn't only in my head, the thinking was on the paper. And if you know Richard Feynman, he invented the Feynman diagrams, and that really facilitated physicists thinking through these complex problems. So he used this idea of externalized cognition to show how cognition occurs outside the head, external to the brain, external to the body. And it's this integration of brain and body that is important to think about when designing spaces. So when we talk about this notion of extended cognition, we talk about this idea of offloading into the environment and scaffolding in the environment. And the illustrations I often use are, if you're in a good meeting and you're in a room with a whiteboard, if it's a fun meeting, if it's an exciting meeting, invariably someone's going to jump up from the conference table, go to the whiteboard, and start jotting the ideas down. And they'll start making a list or something like that. And that's actually an extended cognitive process. What they're doing is what we call offloading. They're taking ideas from inside the head and putting it into the world. And that serves an important purpose. It frees up resources in the head. You don't have to hold that information in your head anymore. You put it out into the world, and you now use that. It's been offloaded into the world. And that moves on to this next part we call scaffolding of cognition, and that's illustrated on the right, where you see what we love to talk about, the whiteboard, but now with sticky notes. And sticky notes were a revolution for this kind of thinking because they're a boon to studying external cognition. And this is another illustration of an exciting kind of meeting because when you're in a furious idea generation phase, when you're working with a group of people, they are continually dumping ideas out into the world. And if you're in a kind of engaged interaction, you'll start working with those ideas. We call those artifacts, cognitive artifacts. And what's interesting to us from the cognitive science standpoint is those artifacts are now mediating the cognition. The cognition is not just in the head, cognition is not just in the air, the voices traveling between people. The cognition is now being mediated by these artifacts that are in the space in which they are interacting. And they're moving with those and using those to create these very complex ideas. And we do this all the time when we bring together interdisciplinary teams because this is how we create our conceptual models in our initial meetings. We want to dump what we know about the problem into the world, and we start to manipulate that and come up with a kind of shared conceptual frame. So this issue of artifacts and offloading is an important one, but we've always been doing that. Humanity has always been offloading cognition into the world, and that's what's kind of frustrating is I think we can do better. We've always used the space around us to think. So for thousands of years, we've engaged in some kind of externalized cognition. We've created artifacts to facilitate cognition in one way or another. And the question we need to ask is, are we doing enough? And these are just some illustrations of modern forms of externalization. There's the whiteboard wall. I don't know if you've ever seen that. You may see them sold in the airport magazines and that you see in the seat in front of you. But they're actually selling these metal pieces that you can put up on walls in your conference rooms, and you can use whiteboards on them. So the entire space is just whiteboards. And the goal is for people to go in there and dump their ideas out into that space and start to using that to facilitate cognition. At least that's the goal. So they're trying to design, we think, to invite this kind of offloading. The more intriguing one, though, is over here on the right, where this is a video Corning has produced. Corning has been very much into what I would call externalized cognition, even though they're not considering that. They've made a series of fascinating videos called A Day Made of Glass. And I only knew of Corning as the kitchen company, but no, they do a lot more than just make kitchen cooking utensils. With A Day Made of Glass, what they're illustrating is the next generation of the home and the office. So this glass is a surface where you can offload and scaffold cognition and interact with a variety of forms of information and knowledge. So this is just an illustration of someone using their mirror to make meetings, to plan for meetings, and they've also had this in office complexes. So you see here, here's a doctor using the glass to diagnose a patient. Here's a meeting room where the glass, they're interacting with them. And one of my favorite examples is actually from science fiction, where in Iron Man's laboratory, where he's in there and he has all of these kinds of glass surfaces where he's thinking through the problem solving using these artifacts, using this externalized cognition. And the point here is, you know, these are illustrations of how we can start thinking more wisely about external cognition and designing a space to solve kinds of complex problems, because we need this kinds of technology. And what I'm going to end with is, are we as humans still only thinking too simply about this? Are we really optimizing this kind of process of externalization? And it's because of the National Academies that we now have this interdisciplinary project where we're working with biologists who are studying space, but it's the space of insects. It's how insects have been designing spaces and evolving spaces for their own kind of collective cognition and collaborative cognition. And I actually met one of these biologists at a National Academies meeting, and we hatched this idea over a beer because we had this similar interest in how the environment influenced thought. She happened to be studying ants and how the structure of the nests influenced their collective behavior. And I says, oh, I'm interested in buildings and how the structure of buildings influences collective behavior in humans. Like, why don't we write like this grant that's about cross-species designing for and looking for these universals that may exist in nature, where we can think about how to optimize the built environment and optimize it such that collective behavior can be maximized. Can we augment cognition through creating better spaces? And if you know even just a little bit about the insect world and the millions of years of evolution behind what they have accomplished, it's incredible. And my favorite example is the termite mound. And the analogy I've heard from people who study this is like, if you look at a termite mound and the complexity of what they've been able to accomplish compared to what humans, it's as if we humans could build a 17-mile-high skyscraper. So these are incredibly complex structures where they have airflow regulations, the gases are regulated, they have little farms in there, and there's spaces and chambers in which they interact and do very specific things. So our goal is to see if we can come up with some kind of interdisciplinary integrations of methods and theories and concepts to do some kind of biomorphic design and think about, well, what can we learn from nature to influence human cognition? How can we build spaces that will augment human cognition and maybe make us as smart as termites? I'll end there.